Okay, just today's topic is just this Wronskian. Wronskian. Why I have picked that one, Wronskian? Because in net, it is the screen is visible now. Screen is visible. Is not it? Okay, I think screen is not visible. Now screen is clear.
Yes,
Yes,
sir, the
sir.
screen is
Okay,
visible now.
okay, okay. Now you see that I have written a term Wronskian. Why I have taken that topic? Because from Wronskian, in every year they are asking questions. In every year, it may be that 1 year is not there, but in almost in every year they are asking questions from Wronskian. And we have some misconcept about Wronskian. We have some misconcept on that topic. On that topic. Okay, what type of misconcept is there? Okay, let us discuss that one. So Wronskian, we shall take. There are two direction to think about Wronskian. One is F and Z are two arbitrary differentiable function. We can take that one, and one side is there. One side is there. Y1 and Y2 are fundamental solution of a special type of a special type of second order ODE. Second order ODE. Second order differential equation. Okay. Second order ODE. Okay. Second order ODE. So first I shall discuss that one. This one. F and G are two arbitrary differential function. So function is there. That means some interval should be there. Some interval should be there. No problem. Now you know already the definition of Wronskian. Is it? You know that one, the term Wronskian? You know that one or not? Say, please say yes or no.
Yes, sir.
Okay, you know that one.
Yes, sir.
Okay, you see that it is our discussion method, not like that one-way interaction. Okay, it is our discussion. Whenever you will find some difficulties, please ask. Any type of questions you may ask. Okay, first thing. Now I draw two statement. One is if F is F and G are linearly dependent. You see that we consider that F and G are both differentiable. Our discussion shall start from here. That means that condition, it is differentiability condition is there. Okay, F and G are linearly dependent. Then I draw two statement. F and G equals to 0 for all x belongs to AB. You write that one. Second statement is B. If FC equals to 0 for all x belongs to AB, then F and G are linearly dependent. Again, you draw another. If Wronskian of if F and G are linearly independent, then Wronskian of fg is not equals to 0, not equals to 0 for some x belongs to AB. For some x belongs to AB. Now we have three statement. We know the definition of Wronskian. Wronskian of two function is that one. That is fg f dash g dash. Here f and g are differential. F and g must be differential function, otherwise we cannot define the Wronskian. Okay. Now tell me, what about the truthness of these three statement? What about the truthness of these three statement? You tell me. আচ্ছা, তুমি রনস্কিয়ান জানো তো?
হ্যাঁ স্যার।
নাও তুমি তাহলে বলো যে এই দুটো তিনটে স্টেটমেন্টের ট্রুথনেস, হুইচ স্টেটমেন্ট ইজ কারেক্ট অ্যান্ড হুইচ ওয়ান ইজ নট কারেক্ট?
থার্ড স্টেটমেন্টটা কারেক্ট।
Third statement is correct. And what about ABC? From other student, I want to know which statement is correct. You see that such type of question, they will asking such type of question. From Wronskian, they will ask a questions of marks 4.7 marks, of 4.7 marks. That means it will be in part C. It will be certainly in part C. They will definitely ask. For today's, after today's class, you will be able to answer a questions correctly of 4.7 marks. Okay. You tell me. You should give answer. You know all these things. Some students told that third is correct. Okay, Preeti Sharko.
Sir, I think for the third statement, if f and g any two function, arbitrary function, and the Wronskian is 0 for some point on the interval, then the two functions are linearly independent. And here is the statement that you have written is the Wronskian is not equal to 0 uh, because of the function, the independence of the functions.
You see that here I have used the term if and then. Is not it? That means their converse part also will be there. No problem. You are saying that converse part, but you see that they are asking both side questions. They may ask both type of statement, implied and implied questions. So I am just asking you that ABC is correct, are correct or not, that statements. Now you tell me the option A.
I think the view option is wrong.
Sir, first and A and C
Answer
is correct.
that means if
A,
yes, if it is they are saying that if A and that means if this out of these three statement, only A and C are correct, is not it? Only A and C are correct. I agree. Yes, A is correct, but I do not agree with you that C, and I do not agree with B also. How? How? You see that you don't have any much more concept on that two one. Okay, but they are asking such type of questions. You see that. Certainly, A option is correct because we know that the function f and g are linearly dependent if and only if certainly linearly dependent if and only if, what happened? If and only if f can be expressed as a linear combination of gx,
G.
where x, and it is true for all x belongs to that interval, and that c does not depends on the interval. C is a constant. It can take only one value, no two value. C is not a variable. Okay, that means C is unique scalar. In vector space term, C is unique scalar. In the term of vector space, we can write C is a unique scalar. Okay, this is the definition. If it is true, then certainly Wronskian of fg, it will be f g f dash g dash. So we replace f by g, then c into g, g, c into z dash, and it will be z dash. So certainly this quantity is 0 for every point of x belongs to AB. It is certainly true. We agree that option A is correct. A is correct. Okay, no problem. Now what happened? If Wronskian is 0 for all x belongs to z, then f and g are linearly dependent. We cannot say that one. We cannot say that one. Okay, we cannot. Let us consider. Let us take f of x equals to, just you take x square, and g of x you take, what can we take? It is x into mod x. X belongs to, you take -1 and 1. You take that one. Can you say that f and g are linearly independent? Can you say that one, that x and that 1 are linearly independent? Can you say f and g are linearly independent? Why? 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 Because
Because here C can be -1 and +1. So
plus 1.
C is not unique.
C is not unique because f of x equals to c into g of x for all it is not equals to x belongs to that interval, -1 to 1. Okay, so it is not certainly linearly independent. Now question is, can you say that g is differentiable? Because our target is to that construction our now our we are going to calculate that Wronskian. Can you say
No,
that
sir. Mod X is not for
mod x
zero.
mod x is mod x is
Not differentiable
so
at zero.
that's why you can say that this function is not differentiable? Is there any theorem? You are going to that wrong. You see that f is differentiable. Suppose two function, phi is a differentiable function, psi is a non-differentiable function. Can you say that their product is not differentiable? Can you say that one?
No, sir. No,
So
sir.
that's so how you have conclude that one? Just you check that one. I shall not discuss here. but we can discuss that one in yesterday's demo classes. I have discussed that one, why it is differentiable. Okay, so Z is differentiable. You can check that one. Z is certainly differentiable. And what will be the derivative? You can find also them. And one more thing is that if you calculate their Wronskian, it will be identically 0 for all x belongs to -1 and 1. If we calculate their Wronskian, since G is differentiable, no problem. You will find that derivative, and from that derivative you can calculate the Wronskian at every point. At every point you can calculate. Okay, it is obviously that it is the Wronskian is identically 0. Clear? I have to explain that one. Should I explain that one? How it is Wronskian 0? Or you can verify that one? Should I explain that one? Or shall I
Sir, we
explain?
will do it.
Okay, you will do it. Okay, you will obviously just what happened? Just you have to calculate their derivative. So it will be better to leave it is 2. So one thing you see that their Wronskian is 0 identically, but you see that your f and g are f and g are linearly
Linearly independent.
independent. So what about the statement this and this? If g equals to 0, then f and g are linearly dependent. So this statement is wrong. Yes or not? Is it?
Yes, sir.
Yes, sir.
Then what about the option C? If f and g are linearly independent, then their Wronskian is non-zero for some point of x. Is it?
Sir, with the same example, sir, it is wrong, sir.
No. That means only option A is correct. So this was our misconception with the books, that Wronskian at initial stage, you have told me that Wronskian is non-zero. F and G are uh, independent, then Wronskian must be non-zero at some point. Instead of that, we can say that two differentiable functions, two linearly dependent differentiable functions have their Wronskian 0. Two linearly independent function, they may have Wronskian non-zero as well as Wronskian 0. But it is true that if Wronskian f and g is non-zero at some point, then f and g are linearly independent. Do you agree with that one? Do you
Yes, sir.
agree? It is
Yes, sir.
true. Why? Because if
Sir,
f and g are dependent, their Wronskian is identically 0. So complementary statement will be what? Wronskian is non-zero, then f and g are certainly linearly independent. But when f and g are linearly independent, then you cannot say anything about the Wronskian. You got my point? And what was
Yes,
that
sir.
our
yes, sir.
discussion? This discussion was for any arbitrary two differentiable functions f and g. Now we move to our discussion for a for Wronskian of two two solution y1 and y2, and I have written at that time what I have written, that it is a solution of some specific type of differential equation. Which type? That specific type is this one, y double dash plus p of x y dash plus q of x equals to y equals to 0. That specific, it is not specific, it is still generalized, but condition is that p and q are continuous. P and q are continuous. You got my point? P and q are continuous. So these continuity are the specific restriction on of such type of question. Okay, we call this differential equation as A. Okay, now suppose y1 and y2 are two solution of that one. Then what happened? They are Wronskian. We can take Wronskian as a function of x. Why? Because y1 and y2 both are function of x. So what will happen? It is y1, it is y2, and y1 dash, y2 dash. So certainly all these things are function of x. All these are function of x. So that's why we are written here wx. Now, it is defined for every point of AB. Every point of AB. Okay. Now, question is, do you know Abel's theorem? Do you know the Abel's theorem or Abel's formula? Abel's formula. Do you know that one? Abel's formula.
Yes, sir.
What is Abel's formula? Abel's formula is that one that Abel's formula is that one. What is that one? You say that okay, during that discussion, just you felt that one, the student who are not attending the classes, I shall not allow them for the next classes. Okay, just you fill that Google form. Okay, just 1 minute.
Hello, sir.
Hmm.
Sir, actually, I was trying to fill the Google form, but the link has been expired. So, sir, how can I fill it again? So, sir, if you can please
Okay,
resend the Google
you
form.
attend the demo classes only. Okay, no problem.
Okay, sir. Thank you.
Okay, in your text box, I have given a Google form. Just you fill that one. You can fill also after the classes, no problem. But I will not share that link in the group. Okay, I will not share
Okay,
that
sir.
one. Okay, Abel's formula is that one. What one? That is, it is comes from that relation px wx equals to 0. So why I call that one? Because sometimes uh, sometimes there may be an options that the Wronskian of a two solutions satisfies a differential equation of which order? Certainly, it is a first order. Certainly, it is a first order. So, if we solve that one, then certainly we shall obtain that one, c into e to the power integration minus px dx. This is, and this is valid for every point of AB. Now, question is, so if we write c into e to the power, we can calculate that integration and put at this is phi x. Put at it is a phi x. Now, from here you see that e to the power phi x is either greater than 0. Sorry, it is e to the power phi x is always greater than 0, e to the power 5x is always greater than 0. So what is the possibilities of wx? So wx may be identically 0 for all x belongs to AB. Wx is identically 0 for all x belongs to AB, or it may happen that it is identically non-zero for all x belongs to AB. So it has two characteristics. Why? Because this part is not a zero part. It is cannot be 0. So only part is that one, the constant. Only part is that constant. It is constant. Certainly it is constant. So if constant part is 0, then it will be independent of x. That means Wronskian will be certainly identically 0. Second thing is that if c is not equals to 0, then at any point of x, it will be not equals to 0. Do you agree with that one?
Yes, sir.
Okay. So it has two characteristics. Wx either identically 0 or nowhere 0. Now, one thing you also mentioned that Wx, if it is identically non-zero, then Wx has two characteristics. It is either 0, greater than 0 for all x belongs to AB, or Wx is less than 0 for all x belongs to AB. Is not it? It is, because you see that if c is negative, then certainly Wx is negative. If c is positive constant, then certainly Wx is positive. Is not it? So
Yes,
you
sir.
see that Wx does not changes the sign. Wx does not changes the sign. Okay. Second thing, you observe that if Wronskian is 0 at a particular point, if second thing you see that if Wronskian W is 0 at a particular point, then that Wronskian must be 0 at every point. Is it true or not? Do you agree that one? If Wronskian is 0 at a particular point, then Wronskian is identically 0. Can you say that one or not? Yes, say yes or no.
Yes, sir.
Yes.
Yes, sir.
Why? Because Wronskian has two characteristics. Either it is identically 0 or it is identically non-zero. So if it is a 0 at particular points, then we certainly say that Wronskian is identically 0. Because it is at some point it is non-zero, at some point it is 0. It cannot happen. Clear? Now it is clear. Now third thing, we observe that one. If y1, y2 are, or we may conclude that one, y1, y2 are linearly dependent. If and only if it is both sides, Wronskian of y1, y2 is 0 for all x belongs to AB. It is 0 for all x belongs to AB. Now our if and only part. Second thing, y1 and y2 are linearly independent. If and only if Wronskian is y1, y2 is non-zero for all x belongs to AB. You got my point?
Yes, sir.
Now, what was our extra condition? Our we imposed that the y1, y02 to solution of some differential equations. If we consider y1, y2 are solution of some differential equation, then their Wronskian must be non-zero if they are linearly independent. And also, if their Wronskian is non-zero for all x belongs to AB, then certainly y1 and y2 are linearly independent. Or more specifically, after joining all these properties, we can say that if Wronskian if Wronskian is non-zero for some point x equals to suppose c, then certainly y1 y2 are linearly independent. Can we say that one? Can we say
Yes,
that
sir.
one or not? It is non-zero at some particular point. Then it is certainly it gives that Wronskian is identically non-zero on for all x
All
belongs to
interval.
AB, because we studied that one. Wronskian has two characteristics. One is either identically zero or it is nowhere zero. It is given that it is a non-zero at some point x equals to c. That means we have the property that Wronskian must be non-zero for every values of x. That means Wronskian is nowhere zero. Clear? Now it is clear to all. It is clear or not? Just you tell me.
Yes, sir.
So so now we are okay. One more discussion is that suppose suppose y1 and y2 are linearly independent. Now what our topic is that one, the relation between the zeros of y1 and y2. What our topic? The relation between the zeros of y1 and y2. We are set up we are our target is here to set up a relation between the zeros of y1 and y2. Let us see. Whenever they are linearly independent. You see that if y1 and y2 are linearly dependent, then every zeros of y1 is also zeros of y2, and every zeros of y2 is also zeros of y1. Is not it? Is it? Because you
Yes,
see
sir.
that y1 equals to c into y2. That means every zeros of y2 is also zeros of y1, and conversely. So for the dependency, it will not ask by any questions, but they may ask for a fourth option, because they are picking three options, and they are confused what can be given to that fourth option. They may ask such type of question that if y1 and y2 are linearly dependent, then every zeros of y1 and every zeros of y2 are same. Is it true? Is it true from definition of dependency? So now here our target is, if they are linearly independent, what is the relationship? Okay, just you tell me, and what are the others property? Here our W of x is that one. It is W of y1 and y2, and it is what? It is that one. Y1, y2, y1 dash, and y2 dash. Don't don't do that calculation y1 y2 dash, that y2 y1 dash. Don't do that. But you see that, can we say that since y1 and y2 are linearly independent, that means W of x is non-zero for all x belongs to AB? Can we say that one?
Yes, sir.
So what happened? That means in that determinant, no row or no column will be zero at some point. Is it true or not? Otherwise your Wronskian will be zero. Suppose at C this row is 0. Then Wronskian will be at that point. What will be that? It is 0. It is 0 or not? It is 0 or not?
Yes, sir. It will be 0.
Then
Y1 and Y2 will be LD.
y1 and y2 will be LD. Certainly. Y1 and y2 will be LD. Now you tell me that means we can say that y1 and y2 cannot have
Common 0.
common 0. Is it okay with you?
Yes, sir.
Second thing, B. If column is 0, then Wronskian will be 0. That means y1 cannot have multiple root.
Yes, sir.
Multiple roots. And similarly, y2 cannot have multiple roots. Second thing is that one. If fourth row is 0, sorry, that second row is 0, then what happened? That means y1 dash c is, suppose it is 0, and y2 dash c is 0. Then what happened? That means they have common extremum at x equals to c. Can we say that one? If
Yes,
this
sir.
is true, that means it cannot happen. This relation cannot happen. That means
No,
what?
sir.
That means we can say that,
They cannot share that point.
yes, that means we can say that y1 and y2 cannot have common extremum point. Extremum point. Is it? Then they cannot have a common extremum point. So these three observations are main observation for your NET exam. And one more thing, you see that y1 and y2 does not have common roots, and this one is, I shall not prove here. If y1 and y2, sorry, you write alpha and beta are two roots of two zeros of, you write zeros of y1, then they are exactly one zeros between one zeros of y2 between alpha and beta. What happened? You see that you take here alpha, your are consecutive, you write consecutive zeros of that term, consecutive zeros of y1 and y2, then there exactly one zeros between one zeros of y2 between that means beta. Here y1 is 0, and here what happened? It is y1 of beta equals to 0. Then there exists at least one zero of that y2 gamma will be 0. You got my point? So if you realize the fact, just you take y double dash plus y equals to 0. Now what will be the independent solution? It will be cos x and sin x. They are fundamental solution. That means they are linearly independent solution of that differential equation. Is not it?
Yes.
Is it? Is it solution of that? Can we say that one or not?
Yes, sir. We can say that.
So if you take x belongs to 0 and pi, Then what happened? At x equals to 0, sin x is 0. So 0 and pi. You see that at pi by 2, the another solution has a 0. Is not it? It is.
Yes, sir.
So what happened? And one more thing is that exactly 1 0 is there. Exactly 1 0 is there. Not more than that. Okay? We can prove that one. We can prove that one, no problem. But exactly 1 0 is there. So such type of questions. So if we ask you problem, suppose y1 and y2 are two fundamental solution. Fundamental solution means what? Linearly independent solution. Fundamental solution of what? Y double dash plus p y dash plus q y equals to 0. In certain interval you write ab. Okay, p and q are continuous. Certainly p and q are continuous. Okay, if y1 has 6 zeros in AB, then can we say that one y2 has at least 5 zeros in AB? Can we say that one? Second thing, y2 has at most, right, at most 7 zeros in AB. Can we say that one? Can we say that one? You see that y1 has how many zeros?
6
6.
zeros. Sir, option B can be true. If that is 5 zeros in that interval.
Okay, alpha 3, alpha 4, alpha 5, alpha 6, and it has 6 zeros. No problem. Now you see that between these, the zeros of y2 will be there, is not it? You say beta 1, beta 2, beta 3, beta 4, beta 5. So y2 has how many zeros? At least 5 zeros. So option is A1 is A2, A is correct. Is not it? Is not it?
Yes, sir.
Second thing, y2 has at most 7 zeros. Yes, this can be also true. Because you see that here starting of zeros, y2 may be there, here 1 zeros may be there, and here it is 1 0 may be there. Is not it? Is it? Is it true or not?
Yes.
So at most 7 zeros. But you can think that how, sir, how it is possible, sir? You take y double dash plus y equals to 0. Then you take how many zeros? It is as 6 zeros. So you take 0 and 6 pi. 6 pi. And you take y1x as cos x. And you take y2x as sin x. How many zeros are there for sin x? How many zeros? How many
The seven
zeros?
zeros.
7 zeros. And how many of cos x? How many of cos x? It is 6. It is 6 or not?
Yes,
What will
sir.
be that point? 3 pi by 2, 3 pi by 2, then 5 pi by 2. Then that will be the zeros of cos x. So at most 7 zero and not more than that. Not more than that. Okay, you got my point?
Yes, sir.
Okay, this one is the main answer of that. So we can think in that way. You got my point? Shall we stop here or discuss something? previous year questions on that topic. You see that only 15 students are there. If you want, then I can discuss some questions from previous year. But also,
Sir, it is up to you. If you wish to continue, you can, sir.
okay, okay. Just you take that 10 minutes time. Okay,
Yeah, sure, sir.
just you consider that one. I have to take that assignment. Yes, this one. Okay. Can you see that one? Is it
Yes, sir.
visible? The question. You see that CSR net February 2022. It is a Wronskian related problem. Okay. Can we conclude that one? Which one will be the answer? You see that this type of equation is there. X1, X2 are two solution of the differential. They are not giving that. They are independent. No, well, it is given. Which of the following statement is true for the Wronskian of X1 and X2? You see that Wronskian is identically 0 in AB. Implies that X1, X2 are independent on AB. Is it true?
No, sir.
No, sir.
So it is correct. Incorrect. W can change the sign in AB. Is it true?
No, sir. It
No.
can't
No,
change
sir.
the sign.
Second thing, W of T0 is 0 for some point E. That imply W is identically 0. Is it
True,
true?
sir.
Exactly, sir.
True,
Certainly.
sir.
It is true. Now W of T0 is 1 for some point T not 0. That implies that W equals to 1. Is it true?
Can't
No,
say
sir.
that.
Not necessary.
Not necessary. So answer is that one. Is there any difficulty for this question?
No, sir.
Okay. Second thing. At every year they are asking questions. Okay. In every year. Just you take that one. Now I am just binding up that one. Amon Ahmed is permitted that one. Okay. No problem. That you see that here the differential equation is what? This one. At W1 it is given A. At W2 it is given B. At W3 it is given C. Is not it? So they are asking such type of questions. Or okay, no problem. They are question such type of question. So what you have to do here, you see that Px is given. So just you calculate Wx. Wx will be what? C into e to the power what? It will be integration minus 1 plus x square dx. That will be what? It is c into e to the power minus x cubed by 3. Is not it? Now you say that, is it increasing or decreasing? Is it increasing or decreasing? You tell me. Is it increasing or decreasing? You tell me.
It will decrease, sir.
Decrease. That means we can say that if c is greater than 0, then w of a, w of 1 is greater than w of 2 is greater than w of 3. Is not it? That
Yes,
means
sir.
a is greater than b is greater than c. Actually, I have done a mistake. Here one option was there. No problem. It is that like that b greater than c. There was a typos. Typical error was there. Okay, no problem.
Okay.
So if C is greater than 0, so automatically it will be decrease. If C is less than 0, then it will be decrease. Sorry, it will be increase. Is it?
Yes, sir.
Then what will be that? Then that part will be A is less than B is less than C. Is not it?
Yes, sir.
So option 2 will be correct. Second thing, whenever option 2 is correct, then you see that A is, sorry, first option, you say that first option, A is less than 0, B is less than 0. Is it true? It is certainly false,
No, sir.
because Wronskian cannot
Change
change
that
the
sign.
sign. So at one point it is negative, at 2 point it is positive. It cannot happen. So either A, B, C, all are positive, or can you say that A, B, C all are negative? All are negative. Can you say
Negative.
that one?
Yes, sir.
All are negative. No, so, and 2 is option is correct. You see that. Third option, A by mod A, B by mod A, C by mod A. So certainly, if A, B, C are of same sign, then equality always hold. Why? How? If A, B, C all are positive, then A by mod A, it will be what? 1. B by mod A, it will be what? Mod B.
1.
1. And C by mod A, it will also be 1. Is not it? So
Right,
they are
sir.
equal. If A, B, C all are negative, then certainly it will be -1, -1, -1. Is not it? Is not it?
Yes, sir. It is.
So option 3 is correct or not?
Yes, sir. It
Yes,
will
sir,
correct.
correct.
And what about the other? A is greater than B, B is greater than C, greater than 0. It can be anything. Negative, positive also be there. So option 4 is not correct. You got the logic?
Yeah.
Yes. Second thing, you go to that questions. You write that one, that problem. It is also from CSN net. You see that y2, y are fundamental solution. That means they are linearly independent solution. It is given. And it is our type equation, is not it? Why? Because px, qx are continuous function on AP. And x0 is a point in that interval. Then, which one is not true? You remind that what we have to determine? We have
Not
to,
true.
not true. That means we have to determine false statement.
False. Yes, sir.
We have to determine false statement. Y1, Y2 both cannot have local extremum at x0. Is it true? Is it
True,
a
sir.
true statement?
Yes, sir.
True,
This
sir.
is true, but not the answer.
Not the answer. Yes.
Yes, sir.
Second one, y1 and y2 both cannot have local maximum at x0. Is it also true?
Yes, sir.
So,
Yes, sir.
but statement is true, but not our answer.
Yes, sir.
Okay.
Not the answer.
Y1 can have local maximum at x0, and y2 can have a local minimum at x0.
Sir, if
That means,
it cannot share extrema, so I think so it cannot
yes,
share these points.
yes, this is a false statement. If this statement is true, then y2, y1 dash x0 must be 0 for minimum, maximum,
Yes, sir.
and for minimum y2 x0 it will be 0.
Yes, sir.
So it cannot happen. That means it
No.
is our answer.
G. Yes, sir.
Then fourth option, y2 and y2 both can vanish simultaneously at x0. Is it true statement?
No, sir. Cannot
No.
share roots.
Yes. That means what? It will be our answer. You got my point? You see
Yes,
that
sir.
we need not to solve anything. We have to answer the questions analytical way. You got my point? Okay.
Yes, sir.
Second thing, you come the questions for the last one. It is a question from NBHM. NBHM. Okay. What happened? Here F is and Z is given. F is this one and Z is this one. F and Z are linearly independent on -1 and 1. Is it true? Is it true or not?
Yes, sir.
Yes, it is true. F and Z are linearly, okay, here you see that it is not independent. One of them must be dependent, okay? Here I have mistake. You take F and Z are dependent on -1. It is certainly not, because A or B complementary statement. And you see that what is third one? Third one is Wronskian of F and Z.
Yes, sir.
It is not identically 0 on AB. You see that if I not discuss that one, that independent function may have identically 0 Wronskian, then certainly you will be done that mistake. You see that
Yes, sir.
here it is also true that it is not true.
Yes,
It
sir.
is not true, because similar way you can calculate that their Wronskian is certainly
Identically zero.
0.
Yes, sir.
Okay, but if you think in that way, that linearly independent vector cannot have a Wronskian 0, then
Zero.
certainly option 3 will be mistake.
Yes, sir.
Okay. Second thing, there exist continuous function px and qx such that f g satisfies such type of differential equation. Answer is will be what?
Yeah. True, sir.
Yes,
No,
sir. True.
no,
Uh,
certainly not true. Certainly
oh,
not true. Why? If f and g satisfies such type of differential equation, their Wronskian cannot be 0.
identically zero. Right, sir. They
And
will be become solutions.
one thing,
Sir.
they cannot have common zeros.
Yes, sir.
They have a common 0 in -1
X
and
equal to
1.
zero. Right.
So it cannot. That means there exists no differential equation that will be in this specific form. That's why I have used that term.